Hello friends, now this is the chapter number 10, straight line. In this video, I will explain first of all some basic concept for the straight line and then the important formulas before the exercise 10.1. I am making the two parts for the exercise 10.1. In first part, I will explain some basic and the formulas and the solved examples, and then next part I will explain the exercise 10.1. I will give the link of my second part in the description box as well as in the comment section. Now let us start. Introduction. We are familiar with two-dimensional coordinate geometry from earlier classes. Mainly, it is a combination of algebra and geometry. The resulting combination of analysis and geometry is referred now as analytical geometry. Now, in earlier classes, we initiated the study of coordinate geometry, where we studied about coordinate axis, that is x-axis, y-axis, coordinate plane, xy plane, plotting of the point in a plane, distance between the 2 points and the section formula, etc. All these concepts are the basic of coordinate geometry. Let us have a brief recall of coordinate geometry done in earlier classes. Okay. To recapitulate, the location of the point 6 minus 4. This point is in the fourth quadrant and 3, 0 in xy plane as shown in figure. Now see this, the point 6 minus 4 is at a 6 unit distance from the y-axis. Okay, this distance is a 6 from the y-axis measured along the positive x-axis. It is measured from this positive x-axis. Okay, along and 4 unit distance from the x-axis. This distance is a 4 unit distance from the x-axis, and similarly the point 30 is at a 3 unit from the y-axis. It is 3 unit from the y-axis measured along the positive x-axis. Okay, and its a y coordinate is a 0. Okay, distance of the point 30 from the x-axis is a 0. Therefore, the y coordinate is a 0. It's simple point, that is a 6 minus 4. It is in the fourth quadrant, and 3, 0. It is on the x-axis. We also studied there are the important formulae. The distance between the point P x1 y1 and Q x2 y2 is the difference of x coordinate, that is x2 minus x1 bracket square plus y2 minus y1 bracket square. This is the distance between the 2 points. For example, the distance between the point 6 minus 4, 30 is. Now here the difference of the first of all, we have the x coordinate and then the difference of the y coordinate. What is the first? x2 is here 3 minus 6. It's a bracket square plus. But what about here? That is a y2. Here y2 is a 0. But y1 is a minus. Therefore, we have here a minus in bracket minus 4. Okay, it's a bracket square. And that minus and this minus, that makes plus. Okay, therefore here 0 plus 4 bracket square and 3 minus 6, you will get minus 3. Minus 3 square is a 9, and therefore here 4 square and 3 square, that is equals to 25, and the square root of 25 is 5. Therefore the distance between the 2 points, given 2 point, is 5. Okay. Now the next, the coordinates of a point dividing the line segment joining the point x1 y1 and x2 y2 internally in the ratio m as to n is mx2 plus nx1 upon m plus n and my2 plus ny1 upon m plus n. Okay, suppose that these are the 2 points. If this is the A point and this is the B, and there is another point which divides the line segment in the ratio m as to n, and the coordinate of the point A is x1, y1, and here the coordinate of the point x2, y2, and therefore for the x coordinate mx2 plus nx1 upon m plus n, and similarly coordinate of the point of the division is my2 plus ny1 upon m plus n. This is the point of division. Okay. For example, the coordinate of the point which divides the line segment A 1 minus 3 and B minus 3 9 internally in the ratio 1 as to 3. Now it divides internally. If it divides, any point divides externally, then we have here minus sign. That is mx2 minus nx1 upon m minus n, my2 plus minus ny1 upon m minus n. Okay. Now for this point, these are the x1 and y1. This is x2 and y2. Okay. Therefore x is equals to, and now here the first 1 will multiply for this minus 3. Okay. And next point is a 3 will multiply to this 1. Okay, minus 3 and plus 3, it's a 0, 0 upon 4. Overall, you will get here 0. What about the next point? That is a my2. Okay, my2, that is a 9, 1 into 9 here, and ny1. Okay, 3 into minus 3. 3 into minus 3, minus 9 plus 9, that makes 0. That is a 0 upon 4. And overall you will get here 0. Okay, therefore the point of division here is a 0 comma 0. Simple multiplication is there. Okay, that is x is equals to minus 3 plus 3 upon 4, that is a 0 upon 4. And what about here? That is a y is equals to 9 minus 9 upon 4, and that is equals to 0 upon 4. Overall here is a 0, and this is also 0. So for the section formula for the internal division. Now next, in particular, if m is equals to n, the coordinate of the midpoint is mx2 plus nx1 upon m plus n, and my2 plus ny1 upon m plus n. Suppose that we have the point like this here. This is the point A and the point B. The coordinate of the point A is x1, y1, and the coordinate of the point B is x2, y2. And the point P divides this in the ratio 1 as to 1. That is m is equals to n. And if we substitute the m is 1 and n is 1, then what you will get, that is x2, 1 into x2, that is x2, plus 1 into x1, okay, which is the x1, and to the denominator there is a 1 plus 1. This is the x coordinate. And what about the y coordinate? That is a 1 into y2, that is a y2, 1 into y1, it is a y1, upon 1 plus 1, and its a bracket is completed. And therefore you can write here x1 plus x2 upon 2 and y1 plus y1 upon 2. And whenever therefore if you have the 2 points, then what about its midpoint? Midpoint is x1 plus x2 upon 2 and y1 plus y2 upon 2 in this way. With the help of this coordinate geometry, that is, we can find out the area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is. Okay, suppose here the triangle is here like this. I have the triangle and A, this is the point x1 and y1. B is a point, B is a point x2, x2, y2, and C is a point whose coordinate is a x3, y3. Okay, and we want to find out the area. We can find out this area with the help of the determinant also, and we can write this area for that area, and that's equals to 1 upon 2. You can remember this also like this. That is a x1, y1, 1. Next is x2, y2, 1. And third is a x3, y3 and 1. Okay. And if we evaluate this determinant, then here you will get 1 upon 2 in bracket x1 into y2 minus y3. Okay, x1 into y2 minus y3. And in this way, x2 in bracket y3 minus y1, x3 plus x3 in bracket y1 minus y3. In this way, you can find out the area of the triangle when the three coordinates of the vertices of the triangles are given. One more example here. For example, the area of the triangle whose vertices are 4, 4, 3, minus 2 and minus 3, 16 each. Okay. Now, what is here? These are the x1, y1, x2, y2 and next is a x3 and y3. Okay, and this way you can get there is a x1 in bracket y2 minus y3 and next is a x2 in bracket y3 minus y1. Okay, and what about the last x3 in bracket y1 minus y2. In this way you can remember this, and if we evaluate it, you will get minus 54 upon 2. That is a 27 square unit is the area of that triangle. Okay. Now again one more thing is that if the area of the triangle is 0, then 3 points A, B, C lie on a line, that is they are the collinear. Okay. Now in this chapter we shall continue the study of coordinate geometry to study properties of the simplest geometrical figure, straight line. Despite its simplicity, the line is a vital concept of geometry and enters into our daily experiences in numerous interesting and useful ways. It plays vitally important role, okay, in the geometry. Okay, main focus is on representing the line algebraically, for which the slope is most essential. When you want to represent a line, then the slope is very important. Okay, now we'll discuss the next topic here. Slope of a line. Slope of a line is nothing but the inclination of the line. Suppose I have the coordinate geometry like this and this is the line. Okay, these are the axes. The line makes an inclination with the positive direction of the x-axis. A line in the coordinate plane forms two angles with the x-axis. This is the first angle, it is acute angle, and second angle is on this side. And suppose it is, I will write here, it is the phi. A line in a coordinate plane form the two angles with the x-axis which are supplementary. Yes, clearly it is a supplementary. They are the adjacent angles, and sum of these two angles is 180, and therefore they are the supplementary. The angle theta made by the line L with the positive direction of the x-axis and measured anti-clockwise is called the inclination of the line. See this here. This is the line L. It makes an angle of theta in a positive direction of the x-axis. Okay. As this angle is theta, what about the remaining angle? These two angles are supplementary. Their total is 180, and therefore this angle is 180 minus theta. Okay. Now the next, the value of this theta is lies between 0 and 180. Equal to 0 also may be possible. Equal to 180 may be possible. We observe that the lines parallel to x-axis, lines parallel, if I draw the line which is the parallel to x-axis, and what about its inclination? It has no inclination. Okay, it has zero inclination, therefore its slope will be the 0. It has a zero inclination. The inclination of vertical line parallel to or the coinciding with the y-axis. Suppose I draw the line which is coincides with the y-axis, and therefore its inclination is a 90 degree. Or if I draw the line parallel to y-axis, then we will say that the inclination of this line is 90 degree. Okay. Now the next, first definition. If theta is the inclination of a line L, then tan theta is called the slope or gradient of the line L. The tangent of that angle is nothing but the slope of that line, or it is also called the gradient, which you study in the 12th standard. What is meant by that gradient? Okay, the slope of a line whose inclination is 90 is not defined. Then how it is? We can write here, that is what about the tan of 90? Tan 90, that's equals to, is not defined. Tan 90 is not defined. Okay, and therefore slope of a line whose inclination is 90 is not defined. Okay, slope of a line is always denoted by this m, small m. Thus m is equals to tan of theta, where theta is not equals to 90. It may be observed that the slope of x-axis is 0 and the slope of y-axis is not defined. Yes, slope of x-axis, the angle made by the x-axis with itself is 0. And what about the tan of 0? Tan 0 is 0. Therefore, if we draw the coordinate axis like this is the x-axis and the y-axis. Okay, the slope, it doesn't has any inclination, therefore its slope is 0, and this is the y-axis. Okay, it makes an angle of 90 degree with the x-axis, and in the trigonometry we have the ratio tan 90. The value of the tan ratio tan 90 is not defined. Okay, this is the not defined. Okay, next, slope of a line when the coordinates of any 2 points on the lines are given. We can find out the slope of line in 2 ways. When its inclination with the x-axis is given, and the another way is that when we know the 2 points of the line. Now the slope of a line when the coordinates of any 2 points on the line are given. This is also very interesting to find out the slope of line when 2 points are given. Now see this here, how to find out that. We know that a line is completely determined when we are given 2 points on it. Okay. We can can find the equation of a line when we know the 2 points of the line. Okay. Now see this here, the x-axis and the y-axis. This line L makes an angle of theta in a positive direction of the x-axis. P and Q are the 2 points of the line x1, y1 and the x2, y2. We can find out here in this, see this here, the triangle PMQ. Okay. PM is parallel to this x-axis and this is a transversal. These two lines are parallel. Therefore, these two angles are the corresponding angles. We can find out the tan of theta from the triangle PMQ. Now, what is the tan theta? Tan theta is a QM upon opposite side upon adjacent side, and next is a PM. Okay, we can find out the QM. What is that? The QM distance. To find out the QM distance, it's a parallel to y-axis, and this is nothing but the difference of the y coordinate. Okay, that's the y2 minus y1. Okay, therefore here we will write y2 minus y1. We want to find out this QM distance. This is the y parallel to y-axis. This is the y distance. We can find out the y2 minus y1. And PM. Okay, the m coordinate, x coordinate of the point M is x2, and the next, the x coordinate of the point P is x1, and we can find out this distance. This distance is nothing but x2 minus x1, and therefore PM is nothing but the x2 minus x1. Therefore, the tan theta is equals to, that is equals to slope M is equals to tan theta y2 minus y1 upon x2 minus x1. That is the difference of y coordinate upon difference of x coordinate. One must see this here. The sequence is very important. If we write here y2 minus y1, to the denominator must be always x2 minus x1. It should not like this x1 minus x2. If the numerator has y2 minus y1, then the denominator must also have the x2 minus x1. If the numerator is y1 minus y2, then the denominator must also have the x1 minus x2. That is here the same thing is here. First is when this angle is a acute angle, we can find out MQ upon MP. Okay, that is equals to tan theta. Therefore, M is equals to y2 minus y1 upon x2 minus x1. Okay, this is the slope of a line L. Now the next is a when the angle theta is a obtuse angle. This angle theta is a obtuse angle. Okay, now extend this line. Draw the perpendicular from Q to on the x-axis and from P to on QR. Okay, as this measure of this angle is theta, and what about the measure of this angle? Measure of this angle is 180 minus theta. Okay, it's very easy. See this here. This is the 180 minus theta. Okay, these are the corresponding lines. These two lines are parallel. Therefore, the measure of angle QPM is equals to 180 minus theta. Now, we'll find out the slope of the line tan of 180 minus theta, and that's equals to QM upon PM. Okay, tan of M is equals to tan theta, tan of 180 minus MPQ. Now see this here by using the trigonometry. Tan of, we know from the trigonometry, that is a tan of pi minus theta, and that's equals to minus tan theta. Okay, and therefore it is a minus tan of MPQ. But again, from this triangle, tan of MPQ opposite side upon adjacent side, MQ upon MP. But what is the MQ? MQ is a y2 minus y1. This distance is a parallel to y-axis. Therefore, it's a difference of the y coordinate. Okay. Therefore, it is a y2 minus y1. Next, we will find out the MP. To find out the MP, the x coordinate of this is the x distance, x coordinate of the point P is x1 and the x coordinate of the point M is a x2, and therefore it is a x2 minus x1 minus x2. Okay. Now we can absorb this negative sign, and instead of that we write here x2 minus x1 by absorbing the negative sign, and therefore this tan M is equals to tan of 180 minus MPQ is equals to y2 minus y1 upon x2 minus x1, and in this way we get the slope of a line M is equals to y2 minus y1 upon x2 minus x1 when the line makes an obtuse angle. Okay. Consequently, we see that in both cases the slope M of the line through the point x1 y1 and x2 y2 is given by M is equals to y2 minus y1 upon x2 minus x1. Okay. Now the next topic, conditions for parallelism and perpendicularity of lines in terms of their slopes. When we say that the two lines are parallel and when we say that the two lines are perpendicular, or what is the condition when the lines are parallel? What is the condition that when the lines are perpendicular to each other? Okay. In a coordinate plane, suppose that non-vertical line L1 and L2 have the slope M1 and M2. Okay. The slope M1 and M2 respectively. Let their inclination be alpha and beta respectively. The inclination of the line L is alpha, inclination of the line L2 is a beta. Okay. If the line L1 is a parallel to L2, then their inclinations are equal to alpha is equals to beta when the lines are parallel. Okay. Therefore, tan of alpha is equals to tan beta. But what is a tan alpha? Tan alpha means what? Slope of the first line M1, and tan beta is the slope of the second line M2. Therefore, M1 is equals to M2. That is, their slopes are equal when the two lines are parallel. Conversely, if the two slopes of if the slope of two lines L1 and L2 is the same, suppose that M1 is equals to M2, then what will happen? Then tan alpha is equals to tan beta. Okay. Therefore, by the property of the tangent function between 0 and 180, we'll say that the inclination made by that two lines are equal. Therefore, the lines are parallel. Okay. And hence, if we have given that the slopes are equal, lines are parallel. Okay. And when the lines are parallel, then their slopes are equal. Hence, two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. Okay. Now the next case is also very interesting. Now the condition for the perpendicularity. If the line L1 and L2 are perpendicular to each other, this is the line L1 and this is the L2. The angle between them is a 90. But one thing is that the line L1 makes an angle of alpha with the x-axis. L2 makes an angle of beta with the positive direction of the x-axis. Now from the geometry, this is also 90 degree. They are vertically opposite. If we consider this triangle, this angle beta is the exterior angle, and measure of this exterior angle, this beta, is equals to sum of its remote interior. That is, a beta is equals to this alpha plus 90 degree, and therefore tan of beta, okay, tan of beta is equals to tan of alpha plus 90. And again, from the trigonometry, whenever there is a like this, tan of pi by 2 tan of pi by 2 plus theta means what? Tan of 90 plus theta. The trigonometry function changes, it becomes cot, and in second quadrant tan is negative, and therefore we have that is a cot theta, and hence tan of alpha plus 90 is a minus cot of alpha. Okay, now this is also very interesting. Here is a tan of, I can write here, tan beta, that's equals to cot of alpha means what? It's a reciprocal of the tan alpha, and here it is a tan of alpha. Okay, therefore tan beta is equals to minus 1 upon tan alpha. Now substitute the values. Tan beta, this is the m2, and tan alpha, it is a m1, and therefore m2 is equals to minus 1 upon m1, and their product m1 into m2, it's a minus 1, and hence when the two lines are perpendicular to each other, the product of their slope is a minus 1. Okay, when the lines are perpendicular, product of the slope is minus 1. What about the converse part? If the line, their product of the slope is a minus 1, okay, the product of the slope is a minus 1, then we say that the lines are perpendicular. And for that, m1 means what? Tan of alpha. m2 means what? Tan of beta. Okay, now the next, then tan of alpha. Now see this here, we can write tan of alpha is equals to, now transform this tan alpha, tan beta to the right hand side. As it is a multiplicative, it will become divided. That is equals to tan of beta, and this is nothing but the minus cot of beta. Therefore tan alpha is equals to minus cot beta. As it has a minus sign, therefore we can write it is in terms of the tan of beta plus 90, or it can be also written as tan of beta minus 90. Tan is negative in the second and fourth quadrant. Okay, and in second quadrant we can write beta plus alpha, and in the fourth quadrant we can write here beta minus 90. Okay, and therefore we have written tan of alpha is equals to tan of beta plus 90, or tan of beta minus 90. Okay, and it implies that, okay, we can write here tan of alpha is equals to tan of beta plus 90. I can write here alpha is equals to beta plus 90 from this. What about the next? Next I can write this alpha is equals to beta minus 90, and in this way transfer this beta to the left hand side. Therefore alpha minus beta, and that's equals to 90. Transfer this alpha to the right hand side and 90 to the left hand side. Then here you will have the difference beta minus alpha, and that's equals to 90, and therefore alpha and beta differ by 90 degrees whenever the product of the slope is a minus 1. It means that the lines are perpendicular to each other, and thus the lines are perpendicular to each other. Hence two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocal of each other. That is m2 is equals to minus 1 upon m1, or m1 into m2 is equals to minus 1, or again we can write here one more, m1 is equals to, sorry, here m1 is equals to minus 1 upon m2. Okay, let us consider the following example. Example number 1. Find the slope of the line. It's very easy question. x1, y1, x2, y2. Therefore, difference of the y coordinate upon difference of the x coordinate. Okay, this is the y2 and this is the y1, y2 and the y1. What is the slope? We can write here x1, y1, x2, y2. The slope m is equals to y2 minus y1 upon x2 minus x1. Therefore, 4 minus in bracket minus 2. This minus and minus that will become plus 4 plus 2, that is the 6. Again minus 1, minus 3, minus 4, and simplify this. You will get 2 by 3 by 2. Therefore, the slope of the line passing through the point 3 minus 2 minus 1 4 is minus 3 by 2. Now the next problem. Passing through the point 3 minus 2 7 minus 2. Okay, and here is x1 and y1, x2 and y2. It's clear that here the y coordinate is the same. As the y coordinate is the same, the given line is parallel to x-axis. As the line is parallel to x-axis, its slope is 0. See this here. The slope of the line passing through the point 3 minus 2, 7 minus 2 is difference of y coordinate. That is minus 2, minus in bracket minus 2. It becomes plus, minus 2 plus 2. It's a 0. 7 minus 3, 4. 0 upon 4, you will get 0. Therefore, the slope of the line is 0. Now the next problem. Passing through the point 3 minus 2 and 3 4. Again here you can observe this. The x coordinate are the equal here. This is the x1 and y1, x2 and y2. When we find the slope of a line whose x coordinates are equal, then that slope is not defined. It's parallel to y-axis. The slope of a line passing through the point 3 minus 2 3 4 is again difference of y coordinate upon difference of x coordinate. 4 minus in bracket minus 2 upon 3 minus 3. This minus and minus that will become plus. 4 plus 2 is a 6. 6 upon 0, which is the not defined, and hence it's a parallel to x-axis. Sorry, parallel to it's a y-axis. Therefore, its slope is not defined. It may be like this. Okay. Now the next problem. Making the inclination of 60 degree with the positive direction of the x-axis. Very simple. We can find out the tan ratio of 60 degree. Here the inclination of the line is a 60 degree, and therefore the slope of the line m is equals to tan 60, and the value of tan 60 is a root 3. Therefore the slope of the line is a root 3. Next topic is a angle between two lines. When we think about more than one line in a plane, that is in a plane when there are the two lines. We have the two lines. Suppose this is the first line and this is the second line. They make an angle of theta with each other. Okay. Yeah. When we think about more than one line in a plane, then we find that these lines are either intersecting or parallel. Here we will discuss the angle between two lines in terms of their slopes. In 12th standard, you can find out the angle between the two lines from the coefficient of that terms. Okay, but here we can find out the angle between the two lines with their slopes. Okay, let L1 and L2 be non-vertical lines with the slope M1 and M2 respectively. Alpha 1 and alpha 2 are the inclinations of the line L1 and L2 respectively. Now see this here, the line L1, it makes an angle of alpha 1 in a positive direction of the x-axis. L2 makes an angle of alpha 2 in a direction with the positive direction of the x-axis. Here M1 is equals to tan alpha, M2 is equals to tan of alpha 2. Okay. We know that when the two lines intersect each other, they make two pairs of vertically opposite angles. See this here. The angle between them here is a theta, and this is also theta. And the angle between these two lines, which is obtuse angle, and this is also two pairs of vertically opposite angles. Okay. Now next, we will find out the relation between this theta alpha 1 and alpha 2. Two pairs of vertically opposite angles such that sum of two adjacent angle is 180. It means that theta plus phi, that's equals to 180. Here theta and phi be the adjacent angles between the line L1 and L2. These are the adjacent angles between the line L1 and L2. Okay. Now this theta is equals to alpha 2 minus alpha 1. If we consider this triangle, measure of this angle is theta. Okay. Alpha 2 is x triangle. Measure of this alpha 2 is equals to sum of its remote interior, that is equals to alpha 1 plus theta, and therefore this, okay, theta is equals to alpha 2 minus alpha 1. Theta is equals to alpha 2 minus alpha 1. Okay. Alpha 1 and alpha 2 are not equals to 90 degree. Okay. Now here theta is equals to, we have alpha 2 minus alpha 1. Take the tan ratio on both sides. Then you will have tan of theta is equals to tan of alpha 2 minus alpha 1. And here we will apply the formula. What is the tan of A minus B? We can write here tan of in bracket A minus B, and that's equals to tan of A minus tan of B upon 1 plus tan of A into tan B. Okay. And therefore tan theta is equals to tan of alpha 2 minus alpha 1 means what? Tan of alpha 2 minus tan of alpha 1 upon 1 plus tan of alpha 1 into alpha 2. But the alpha 2 means what? It's a slope of the second line. That is nothing but the M2. Alpha 1 means what? Slope of the first line. It's nothing but the M1. That is M2 minus M1 upon 1 plus M1 into M2, where 1 plus M1 into M2 is not equals to 0. And hence, when the slope of the two lines are given, we can find out the angle between them. This theta is the angle between that two lines, M2 minus M1 upon 1 plus M1 into M2. Also, when we consider this angle between them is obtuse angle, this phi is equals to 180 minus theta. Again, take the ratio, tan ratio on both sides, that is a tan of phi is equals to tan of 180 minus theta. Okay. Tan of 180 minus theta, it goes in again in the second quadrant, and whenever there is a pi angle, the function remain as it is, and you will have here minus tan of phi. It is in the second quadrant. Okay. Therefore tan phi is equals to minus tan of theta. But we know the value of the tan theta, that is M2 minus M1 upon 1 plus M1 into M2. This is the tan phi. Again, 1 plus M1 in M2 is not equals to 0, and hence tan of phi is equals to minus M2 minus m1 upon 1 plus m1 into m2 when this phi is a obtuse angle. Okay, and when the theta is a acute angle, then we have it's a positive sign. Again, now here arises the two cases. The first is if m2 minus m1 upon 1 plus m1 into m2 is a positive, then tan theta is positive and tan of phi at that time will be the negative, which means theta will be acute and phi will be obtuse. And in second case, suppose that m2 minus m1 upon 1 plus m1 into m2 is negative, then tan theta will be negative and tan of phi will be the positive. And thus, the acute angle theta between the lines L1 and L2 with the slope m1 and m2 respectively is given by tan theta is equals to m2 minus m1 upon 1 plus m1 into m2. That is when the two lines are in a plane, they intersect, and if we know the slope of that two lines, we can find out the angle between the two lines. Okay, where m1 plus m2, where 1 plus m1 into m2 is not equals to 0. Okay, now the next problems. If the angle between the two lines is pi by 4, okay, angle between the two lines is pi by 4, slope of one line is 1 upon 2, find the slope of the other line. Okay, angle between the two lines, see this here, the first line, angle between first line is here, first line whose slope is 1 upon 2, we have written here, and this is the second line. Okay, and the angle between them is 45. Okay, now we'll find out the slope of this line. We know that the acute angle theta between the two lines m1 and m2 is given by this formula. Substitute the value. Here we take here m1, that is 1 upon 2, and we want to find out the slope of the line, another line, which is the L2. Okay, and therefore m2 is equals to m. We will substitute m2 is equals to m. Theta is equals to pi by 4. Substitute all these values. Therefore tan of pi by 4, m2 is replaced by m, m1 is replaced by 1 upon 2. Substitute here value 1 plus 1 upon 2 into m. Tan of pi by 4 is 1, m minus 1 upon 2 upon 1 plus 1 upon 2 m, and now simplify this. If we draw this mod sign, then we will have 1 minus 1 upon 2 upon 1 plus 1 upon 2 into m. Once we will take here plus sign, and in second time we take the minus sign when we evaluate this type of the modulus. Now evaluate this. The first is 2m minus 1 upon 2. Again this whole divided by 2 plus m upon 2, and that's equals to 1. What about here? Here is also 2m minus 1 upon 2, and again this divided by 2 plus m, 2 plus m upon 2, and that's equals to minus 1. These two get cancelled, and we can evaluate this 2m minus 1 upon 2 plus m, and that's equals to 1. Or here this 2 will get cancelled, you will get 2m minus 1 upon 2 plus m, and that's equals to minus 1. Therefore 2m minus 1 is equals to 2 plus m, or 2m minus 1 is equals to minus 1 into in bracket 2 plus m. Now evaluate this. 2m minus m, that's 2, this minus will become plus 1. Therefore m is equals to 3. And what about here? If you evaluate this, 2m minus 1, that is equals to minus 2 minus m, and there this minus m will become plus m, and overall it will become 3m, this minus 2 and this minus 1, if we transfer, it will become plus minus 1, and therefore here you will get m is equals to minus 1 upon 3. Therefore here we have the m is equals to 3 and m is equals to minus 1 upon 3. If m is equals to 3, this is the angle between them is a 45. Okay. Now here the line, this makes, and first it makes an angle of acute angle, and in second case it makes an obtuse angle. Okay. Therefore here m is equals to 3 or m is equals to minus 1 upon 3. Hence slope of the other line is a 3 or minus 1 by 3. Now the next problem. Line through the point minus 2, 6 and 4, 8 is a perpendicular to the line through the point 8, 12 and x 24. Okay. The line passes through these 2 points. Okay. It is a perpendicular to the line passes through these 2 points. Okay. Means what? We'll find out the slope of these 2 points. Slope of the first line, slope of the second line, and product of their slope is a minus 1. Slope of the line through the point minus 2, 6, 4, 8 is again difference of y coordinate 8 minus 6 upon 4 minus in bracket minus 2. This minus and minus, that will become plus. 4 plus 2, 6. 8 minus 6, that is a 2, and overall you will get 1 by 3. Slope of the line through the point 8, 12 and x 24. Again the difference of y coordinate 24 minus 12 upon x minus 8. 24 minus 12, you will get 12 upon x minus 8. Since these two lines are perpendicular, product of the slope is a minus 1. 1 by 3 into 12 upon x minus 8, that's equals to minus 8. And if we simplify here, that is a 12 is equals to 3 in bracket x minus 12, or you can simplify here 3 ones are and 3 fours are 12. Here you will get, that is a 4 upon x minus 8, and that's equals to minus 1, and therefore 4 is equals to minus in bracket x minus 8, and therefore 4 is equals to minus x plus 8, and therefore x is equals to 8 minus 4, and that is equals to 4. Therefore we have the value x is equals to 4. Okay. This way we can find out the value of the x. The next concept is a collinearity of the 3 points. When we say that the 3 points are collinear on a line, it's very simple. Slope of AB is equals to slope of BC. Then we say that the point ABC are the collinear. Here we know that the slope of the 2 parallel lines are equal. If 2 lines having the same slope pass through the common point. Then the two lines will coincide. Hence, if A, B, C are 3 points in xy plane, then they will lie on a line, that is 3 points are the collinear. Okay. If and only if the slope of AB is equals to slope of BC. Okay. Now the example, 3 points P, H, K, Q, x1 by 1 and R, x2 by 2 lie on a line, show that they lie on a same line, and we want to show that in bracket h minus x1 into in another bracket y2 minus y1, and that's equals to in bracket k minus y1 into in another bracket x2 minus x1. Okay. Now as these points lie on a same line, they have these points are collinear, and therefore the slope of PQ is equals to slope of QR, that is a y2. So first of all, slope of the PQ, difference of this y coordinate y1 minus k upon x1 minus h. This is the slope of the PQ. Slope of QR. Okay. Slope of this QR y2 minus y1 upon x2 minus x1. Okay. And here we can write it as like this. Take the k minus y1 upon h minus x1. Take the negative sign common from the numerator and the denominator. That negative upon negative, that will become plus. We are doing this because we want to prove this like. Okay. And after the cross multiplication, that is k minus y1 into x2 minus x1, it is here. And y2 minus y1 into h minus x1, it is to the left hand side, and hence we have proved it with the help of collinearity concept. Now the next. In this example, that is in figure, time and distance graph of a linear motion is given. Time and the distance graph in a linear motion is given. Of a linear motion is given. 2 points of time and distance are recorded as, what is the first? Time is 0, distance is 2. And when? Time is 3, distance is 8. Using the concept of slope, find the law of motion, that is how distance depends upon the time. Now see this, the coordinate geometry, this x-axis and the y-axis. On x-axis we are considering the time, and on y-axis we are considering the distance. In first case we have given the time is 0, at that time the distance is 2. This distance, time is 0, at the time distance is 2. In second case, the time is 3, distance is 8. And this is the general point, time and the distance. Here we will find out the slope of first 2 points and the slope of the second and the third point. Okay. Let TD be any point on the line, where the D denotes the distance at a time t, and therefore the points 0 to 3, 8 and the TD are the collinear. And so that find out the slope of these two first of all, 0, 2 and the 3, 8. 8 minus 2, 3 minus 0. Okay. Difference of the distance, first of all, 8 minus 2. Difference of the time, 3 minus 0. What about the next? 3, 8 and the TD. T minus 8 upon T minus 3. And again, what is here? This is the 6 upon 3. That's equals to D minus 8 upon T minus 3. Make the cross multiplication, and after simplification, here you will get here 2 in bracket, this is a 3 ones are and 3 2s are 6. That is a 2 in bracket T minus 3 and that's equals to d minus 8. After the simplification here, 2t minus 6 is equals to d minus 8. Okay, and now the next d is equals to, this d is equals to 2t minus 6 plus 8. Here 2t plus 2, take 2 as a common, and then in bracket you will get t plus 1. Okay, d is equals to 2 in bracket t plus 1, which is the required relation. Okay, and again you can see this, and in this way we have completed all the solved examples and some basic information. Now in my second part for this exercise, I will explain the exercise 10.1, and the link of this video I will give in the description box as well as in the comment section. Now this way we are completing this first part. Now we'll see in the next video. Till then, goodbye.